Today topic is the fundamental of thermodynamics. In fundamental, we have to understand about the basic term of the thermodynamics. Okay. First, introduction of the thermodynamics. So thermodynamics is the science of energy transfer and its effect on the properties. So that is the definition. As you know that when a system receive any type of energy, so already inside the system initial properties change if the energy interaction. Okay. Second point, main aim is to convert disorganized form of energy into organized form of energy in efficient manners. So first of all, understand about the disorganized form of energy. It is a heat energy because the heat atoms in very random manners as compared to organized form of energy. It is a work is in a ordered form. So if you want a work in a particular direction, it is happening. But in heat is convey or push up in one particular direction. It is not possible to goes in particular direction. Okay. So that means heat energy is converted into work. So this device is a heat engine and which is converted in efficient manners, and this already understand that this statement is follows the Calvin Planck statement. Okay, that next point, based on microscopic approach which does not require knowledge of behavior of individual particle. Okay, so macroscopic approach, it is the average behavior of the matter or a system's properties. Okay, it is not a individual, so individual behavior basically in which approach, it is a microscopic approach, and average behavior is macroscopic approach. So macroscopic approach, it is also called as a classical thermodynamics, and microscopic approach, it is called statistical thermodynamics. So statistical thermodynamics, basically it is analysis very difficult as you are a student, so it is a very scientific research person has to do such type of calculations. Okay, next slide. So what is the system surrounding boundaries? So first we have to know about the what is the system. So system is a defined or a prescribed region and that you have interest to any calculation or research. Okay, so the thermodynamic system is defined as the quantity of a region in space chosen for study. Okay, that you focused. If you focused anywhere, you have to focus in the system. There system having many number of subsystems. So if you goes particular area, so it's become a system. Okay, so system having the surrounding, and surrounding it is the outside the systems, and which separate the system and surrounding, it is called boundaries. Okay, boundaries may real or is imaginary. And universe is the sum of the system and surrounding, as you see in the pictures. That is the surrounding, and it is the universe, and it is a system, and this is the boundaries. Okay, that is easy to understand that. Okay, next, types of system. So there are the three types of system in thermodynamics. As you see in pictures, uh, it is the open, and it is a close, and it is isolated. In open, there is the lid is open, and in close, the lid is closed, and in that lid is also closed, and the boundary is also boundary of that of this system is closed. So in that open system, the mass and energy that cross the boundaries, so it is a chemical thermodynamics examples. It is a beakers in that have some solution. If we have to uh, pour this solution, it is goes out, so that means masses and some energies across the system. If a lid is closed, so that neither there is no masses goes out, but energies cross the boundaries. In isolated, no mass and no energy cross the boundary, because this lid is this lid is doesn't flow the mass, and this isolated covers is doesn't cross the energy. Okay, this is a chemical thermodynamics example, but we have to see also some mechanical system basis. Next slide. Closed system. Closed system consists of a fixed amount of mass, and no mass may cross the system boundaries, but energy in form of heat and work may cross the system boundaries. And this closed system boundary may move. Example of this closed system: seal tank, piston cylinder device without valve. Okay, these are the closed system example. Okay, this is a closed system. Energy that is interact and energy it out, and this energy may in form of work or heat, and this energy it is out is in form of heat and work, but there is no mass is goes out from that system. Okay, so mass doesn't cross the boundaries, but energy is across the boundaries. Okay, open system. Open system in that mass and energy does cross the boundaries, but cross the boundaries. Okay, but in closed system, mass does not cross the boundaries. Okay, so open system is also a control volume types, because the boundaries of that system is fixed, and control volume and control surface. And open system are the pump, compressor, steam turbine, valves, and heat exchanger. They are the maximum number of devices that exist in that open system. It is widely used thermodynamic system. Okay, in that energy in and energy that is out, mass in and mass out, they are both things uh, cross the boundaries. Isolated system. Isolated system is that there is no interaction of the work and mass. That means anything doesn't cross the boundaries, and no energy and no mass comes to the isolated system. So it is very uh, isolated. In that you have see this is the isolated system, and no mass is transfer. Okay, and no energy transfer. Okay, so it is like a refrigerator box, or can say that is a universe type. Universe is also called a isolated system. Okay, so isolated system is makes with the help of insulated cover. If the insulation is not there, so that is not isolated system. And thermal flask is also called as a isolated system, and that is a insulated glass insulated walls, so it does not cross the uh, heat to the surroundings, and the lid is closed, so it is not cross the mass from that system. Okay, this is the isolated system. Next, this is the closed, open, and isolated system. These are the types: closed, open, and isolated. On the basis of energy, this system has cross the energy is comes or not comes. So energy is comes and goes out the system, energy comes and goes out the system. In isolated, no energy comes to the system and no energy goes out to the isolated system. Okay. Mass transfer. So in closed system, no mass transfer. Open is mass transfer is exist, and to isolated, no. So example is a gas in a sealed container, turbine, pumps, valve, and compressor. Many example of that. Steady flow energy equation types of you have some applications. It is basically related to this open system, and isolated is the universe and thermoflask. Okay. Next slide. Properties of a system. Any measurable characteristic of a system in equilibrium, it is called properties. Okay. Measurable. Okay. If a property is measurable form, it is good. If a property is not measurable, so there is no benefit of that property, because we have to calculation uh, for finding the work and heat. If no property is utilized because this property is not calculated in well manner, so it is not good. So we have to such a property takes who's measurable. Okay. Measurable characteristic, something provide the behavior of the system is like a pressure, temperature, and volume, like that. And property is independent of the path used to arrive at the system condition. Okay. Properties are the point function. Properties are the exact differential. Property may intensive and extensive. Okay, these are the characteristic of the properties that we have to understand, that either these characteristics not there, so property is not benefited, and so it is not also a properties. Next, extensive properties. Extensive properties, that means it is depends on the mass and size of the systems. Okay. So those properties, if there is one system, another system we have to add it, so they are added in extent. Okay. If the property is not added, so that is the intensive properties, but added, so that is mass is added, volume, total energy, electric charge, magnetics, internal energy, enthalpy, entropies. So so these are in form of a quantitative manner, so it is extensive properties. Basically does depend on the size of mass. Okay. Intensive properties. Intensive properties are independent of the size or the mass of the systems. So some of the intensive properties are pressure, temperature, density, velocity, viscosity. These are the properties are intensive properties. Okay. These properties are measured with the help of instruments. Okay. They can easily measured. Okay. These are very important properties. Okay. And specific properties also called as intensive properties. Also, extensive property divided by unit mass is also called as intensive properties. Okay. Next, important point with respect to properties: extensive properties per unit mass are intensive properties. For example, specific volume. So specific volume is the volume divided mass. So volume is the extensive properties, and mass is also extensive properties. Extensive equal to intensive. Okay, like that. It is a system whose properties m, v, t, p and rho. These are the properties. If the system is break into two part, so mass is break in half and volume also half, but temperature is not half, pressure is not half, and rho is not half. So temperature of that both 1 and 2 compartment is same, pressure also same and density also same and temperature also same, but mass is half and volume is a half. So these half terms is the extensive properties and not a half property is the intensive property. Is very good example for to understand that. Thermodynamics equilibrium. A system is said to be in thermodynamic equilibrium if it maintains three conditions. If maintain thermal equilibrium, in thermal equilibrium the equality of temperatures, in mechanical equilibriums means equality of force and pressure, and chemical equilibrium equality of chemical potentials. Okay, so any any state of a system, it does not change automatically, so it is in form of stable. If the starting of any process and before starting is the unstable form, so that process is not in a thermodynamic equilibrium. So these properties should follow. During okay, during the process, starting of the process, the temperature is changed before starting, so it is not a thermal equilibrium. If the transforming of this energy, the uh, part of the system is deform and something act, so that means mechanical is not good. Chemical stability is not good, so that means it is not a thermodynamic equilibrium. So it is, this is the example before and after 20, 23, 30, 35, 40, 42, after 32. Okay, so in that it is in equilibrium. Okay, next slide. State, path and process. Condition of a system is defined by property of system is known as state of a system. Okay, कंडीशन ऑफ ए सिस्टम जो सिस्टम की दशा को बताता है, इसकी क्या कंडीशन है, ठीक है। और दशा किससे पता करते हैं हम? उसकी प्रॉपर्टी से, प्रेशर टेम्परेचर क्या है और पर्टिकुलर जगह पे उसको स्टेट को। ओके, तो स्टेट बहुत सारी हो सकती है एक प्रोसेस के अंदर, ठीक है। और एक स्टेट से दूसरी स्टेट ये प्रॉपर्टीज़ चेंज होती हैं। और एक स्टेट एक प्रोसेस से मतलब कोई भी एक प्रोसेस एकम्प्लिश करने के लिए हमें एक पाथ की ज़रूरत होती है, और पाथ दो स्टेट से बनता है। ओके, तो सीरीज ऑफ स्टेट through which through which through which the process occurs is known as path of the system. Any change of the state is called process. Some processes are isobaric, isothermal, isochoric, isentropic. Isobaric means constant pressure, isothermal means constant temperature, and isochoric means constant volume, and isentropic means entropy. Some one process is polytropic also. Okay, and as you figure, that is state 1 and it is a state 2, and when state 1 property something and state 2 something property, so if If the process occur, they have a series of state. Okay, that thermodynamic cycle. A system is said to be undergoes a cycle if initial and final points are same. Okay, we have to go via path A to B. Via path A to 2 and 2 to A via path B. So it in that a cycle if initial and final points are same. So 1 and 2, it is goes this path and again return to origin point, so it is finished at the same starting point. Okay, so minimum number of process required for the cycle are 2, because the two process, one process and two process, both process basically is the path. So in that there are two path. Cycle change in property is equal to 0. So जो भी आप देखते होंगे, जो वन स्टेट पे से स्टार्ट किया, टू स्टेट पे गया, फिर लौट के ही यहाँ आ गया, तो दैट मीन्स जो उसकी इनिशियल स्टेट है वहाँ की प्रॉपर्टी में तो कुछ चेंज नहीं आया ना, तो फाइनली दैट मीन्स चेंज इक्वल टू 0. Pure substance. Each substance is said to be pure if it is homogeneous in chemical composition and homogeneous in chemical aggregation. For example, pure substances are atmospheric air, steam water mixtures, and combustion product of the fuels. Okay, and phase solid, liquid, and gas is not considered while determining the pure substance. Okay, this is basically fundamental knowledge of the thermodynamics. Okay, thank you.